In this section, we will review aggregate tables. The term to aggregate data is to provide a high-level summary of the key information we are reviewing. If you are used to working with spreadsheets, this would be similar to creating a pivot table. When aggregating data, we will group our information by a number of attributes. The first attribute I typically consider for aggregation would be related to time. For example, if I'm reviewing customer transaction data, I may want to aggregate this data on the hourly level if I was looking at a specific narrow band of time and wanted to identify key hours during the day when customers are visiting our website. Next will be daily level information to identify given days of the week when customers are most active, followed by more broad time ranges such as week, month, quarter, and year. When reviewing any data, it is good to build up both a narrow and broad view of your data, similar to if we were trading foreign exchange or stock options. For foreign exchange markets, as these are very volatile, we would expect to be looking at 5-minute to 30-minute intervals, as currency fluctuations can change dramatically throughout the day. Versus more long-term stock trading options, we would probably only consider weekly, monthly, and yearly trends, where we are not concerned too much by daily activity and are trading on a more long-term basis. So choosing your right time interval can be very much dependent on the business you are conducting and how often you need to react to your data. As a data analyst, you may only be required to look at events after they have happened, so daily, weekly trends are probably as granular as you need to go for your review. However, if you were working in a live environment such as in a NOC, a Network Operations Center, as a systems analyst, then you may very well be displaying trends on a 5-minute and 30-minute interval checking network loads. Or you may be working for an online gaming company reviewing live tournament action and thus having to ensure that servers are stable and players are experiencing the best performance from your servers. After we've identified our time-based aggregates, we then need to consider what other key attributes we want to group our data by. Likely candidates would be to start with country if you are conducting business on a global or regional scale. Then having your data displayed by country will also mean that you can rank or order your key metrics accordingly. Next will be to group your information by your product, which will allow you to identify which products are performing the best and similarly which ones are not performing as expected. Or you may be running a campaign against a specific set of customers and want to check the performance of this campaign, so you have created a query to identify the performance of your campaign over the time. For your campaign, not only do you need to check for each country the performance of your campaign, but also by associated products within each country. In this scenario, we have had to create an aggregate with a combination of attributes for review. And while we can query each attribute separately, such as by time, country, product, or overall campaign, it is also useful to look at our information using a combination of attributes, such as we may want to identify which country had the best performance for a campaign, and within that country, what was the best overall performing product. Reviewing the top product for your top country, we can then try to identify how this product performs in corresponding countries. And based on the outcome of this campaign, we may want to try and establish a further campaign that better targets our top product in our top country in other countries. And to ask the question, why is our top product not performing as well in other countries as we would expect it to be? Once we have identified the key attributes, we now need to look at the key metrics, or KPIs, key performance indicators. Below I've given an example of 3 metrics: sum, count, and maximum. From our fact table example, you can see that I've provided a sample of customer transactions for the month of January on a daily basis for the UK, along with payment total and the corresponding temperature in degrees Celsius at the time. If you are an online retailer, then having temperature data may be very important for your business if your business is partial to seasonality and changes in weather. Identifying such seasonality can help to better understand your overall business model when inferring a hypothesis. In the second table, AG Customer Payment Month, this table describes customer payment transaction data at a monthly level. Hence, we have a prefix for the table of AG, short for aggregate, and a suffix at the end of the table, month, to denote the level of aggregation in the table is at a monthly level. Similarly, we could have additional aggregate tables for daily, weekly, quarterly, and yearly, with each aggregate table providing a summary of the corresponding key performance metrics for that period of aggregation. In our aggregate table example, we can see there is only one row of information at the monthly level, providing us with payment total, a distinct customer count, and the maximum temperature for the given month. Later on, when we visit aggregate tables in our SQL coding, I will also identify some pitfalls to watch out for when aggregating data. To summarize, aggregate tables are useful for summarizing general business information over given periods of time. For an analyst, these tables are invaluable as they can cut down dramatically the time required to answer business questions without having to query low-level fact table transaction information. In time, we will be looking at building our own aggregate tables to answer queries we have, and going forward, if we are building out standard dashboards and reports, we are likely to reference our own created aggregate tables or standard aggregate tables as created by the database administration team. This concludes this section on aggregate tables.